It may be the most iconic image in all of astronomy. A giant rock hurtles through space and crashes violently into a planetary surface. It's been thought for many decades that such a kinetic impact was the cause of the demise of the dinosaurs about 65 million years ago. The heavily pockmarked surfaces of airless worlds such as Mercury and the Moon seem to testify to the routine nature of mechanical collisions in our solar system. On our own planet, it's thought that the reason meteors explode as they enter Earth's atmosphere is due to chemical ablation, thermal heating, and atmospheric pressure. The notion of an enormous rock slamming into our planet is indeed very frightening. The public affairs arms of the world space agencies have pled for increased funding for Earth defense against asteroids, comets, and meteors. However, it's important to remember what has actually been observed in modern times, when planets have encountered cometary and meteoritic intruders. Not only have we not seen collisions or explosions that can be explained by simple mechanical models, but in fact, the energetic phenomena may demand an entirely new way of seeing all celestial objects in our solar system. First, let us consider the common assumptions about so-called impact events, assumptions which continue to shape scientific investigations today. According to a new paper published in the journal Scientific Reports, an asteroidal impact wiped out an entire Middle Eastern city about 3,600 years ago. A team of investigators conducted a decade-and-a-half-long investigation into the region known today as Tal el-Hammam. Based on their painstaking research, the total of 21 authors, including geochemists, geologists, cosmic impact specialists, and other scientists, have concluded that a massive fireball produced an explosion roughly the equivalent of 1,000 Hiroshima atomic bombs. As seen in this image, excavations of the region revealed the ashen, melted ruins of a lost city. The evidence of a catastrophic firestorm is undeniable in the form of melted metal, mud bricks, and pottery. Electron microscope images revealed shocked quartz, which form at hundreds of thousands of pounds of pressure per square inch, as well as tiny diamonds and spherules, whose formation require temperatures of thousands of degrees. The team of scientists described their conclusions as follows. Together, all this evidence shows that temperatures in the city rose higher than those of volcanoes, warfare, and normal city fires. The only natural process left is a cosmic impact. The same evidence is found at known impact sites, such as Tunguska and the Chicxulub crater, created by the asteroid that triggered the dinosaur extinction. However, the claim that the only natural process that can produce superhot temperatures and devastation similar to a cosmic impact is not science fact. Rather, it's an unexamined assumption. In several moments, we will examine the compelling experimental and observational evidence that high-energy electrical discharge is a natural process which has shaped the surface of every solid body in the solar system. Let us consider first what we should expect if an object such as an asteroid or comet closely encounters a planet. On just 2 occasions in modern times, scientists have had the opportunity to anticipate such an event. In 1994, when the comet Shoemaker-Levy 9 approached the planet Jupiter, and again in 2014, when the comet Siding Spring approached Mars. On both occasions, the actual observed interactions between the comet and planet were so unexpected, they should have forced a reassessment of the very foundations of comet theory. Prior to Shoemaker-Levy 9's encounter with Jupiter, some astronomers predicted that the fragments of the comet were too small to have any significant effect when they hit the gas giant planet. The late Eugene Shoemaker, the comet's co-discoverer, said, "There's a chance we will see very little." Likewise, the renowned astronomer Brian Marsden stated, "It's going to be tough to see much. I don't think there's going to be a very large explosion." But as we've repeatedly outlined on this series, the comet's apparent electromagnetic influence on the Jovian environment was vastly more dramatic than standard theory has ever been able to explain. The anomalies included unusual and energetic auroral activity immediately after the quote impact of the largest comet fragment, as well as the disruption and amazing brightening of radiation belts, and unexpected X-ray emissions. As Michael Klein of JPL said in an analysis of the event, Never in 23 years of Jupiter observations have we seen such a rapid and intense increase in radio emission. Extra electrons were supplied by a source, which is a mystery. What planetary scientists had actually expected was that dust debris from the comet would instead cause the radiation belts to dim. Satellites tracking the comet fragments unveiled yet another mystery. Some so-called collisions that were projected to occur just beyond Jupiter's limb, which should have been invisible to all but the Galileo spacecraft, were seen by telescopes on our own planet. NASA's Andrew Ingersoll stated at the time, "In effect, we are apparently seeing something we didn't think we had any right to see." In other words, the electric comet theory would predict dramatic discharge activity high in Jupiter's ionosphere, prior to the comet fragments striking the upper atmosphere. And this is exactly what was observed. And the electrical nature of the event was confirmed by the 3,000-kilometer-high vertical jets seen above Jupiter's clouds, which then fell back to the planet to form these mysterious, crescent-shaped dark features. Simply put, the error is to view both the planet Jupiter and the approaching comet fragments as electrically inert. The electrical nature of the event is at least partly affirmed by the data from NASA's recent Juno mission to the gas giant, including the discovery of electrical potentials in the millions of electron volts, which drive the planet's aurorae, and a vastly more powerful magnetosphere than standard theory had ever imagined. The electric universe theory has always stated that most comet activity comes from the comet, which acquires a, quote, negative charge with respect to its environment in the outer reaches of the solar system, discharging electrically as it enters a more positively charged domain. In the case of Shoemaker-Levy 9, when it encountered the incredible magnetosphere of the planet Jupiter, the discharges were unusually catastrophic. Similar lessons can be gleaned from comet sighting Spring's encounter with Mars. NASA's MAVEN spacecraft measured the effects of the comet on the Martian atmosphere. According to a NASA report, quote, "Debris from the comet added a temporary and very strong layer of ions to the ionosphere, the electrically charged layer high above Mars." MAVEN team member Jared Espley said of the comet's stunning influence, "We think the encounter blew away part of Mars's upper atmosphere, much like a strong solar storm would. The main action took place during the comet's closest approach, but the planet's magnetosphere began to feel some effects as soon as it entered the outer edge of the comet's coma." In fact, the electric universe prediction of a negatively charged comet dust tail has recently been confirmed. In late 2018, scientists studying the, quote, weird striations in the dust tail of Comet McNaught were amazed to conclude that the dust is, quote, electrically charged, and its motion is dramatically affected by the solar wind. Of course, even though some asteroids have occasionally, and to the complete surprise of space scientists, produced cometary displays, including collimated jets, they are not typically nearly as electrically dynamic as comets. Nor does our own planet have nearly the electromagnetic energies seen at a gas giant such as Jupiter. Yet in our electric universe, any intruding body that enters our planet's atmosphere from far away will be differently charged, and can thus discharge electrically. Testimony to these facts can be seen in the dramatic flaring and explosion of a meteor. Indeed, in recent years, mainstream science has begun to recognize the electromagnetic phenomena intrinsic to meteoritic displays. This includes unusual radiophonic noises, which eyewitnesses have reported for many centuries in association with meteor sightings. While mainstream science still holds that a meteor's bright glare, flaring, and disintegration are the result of chemical ablation and atmospheric pressure and heating, abundant evidence suggests that these phenomena also involve electrical discharge activity. A 2005 Thunderbolts article by Michael Armstrong and Jim Payet on the famous Peekskill meteor states, "One proposed explanation, with which the electric universe would agree, is that meteors and spacecraft trigger the formation of instabilities in plasma layers. The energy of the flickering and flaring, as well as of the low-frequency radiation, comes more from the ionospheric plasma than from the meteoroid. The meteors that we've come to think of as, quote, burning up in the atmosphere may instead be the targets of mini thunderbolts from the ionosphere." This viewpoint finds support in the most noted meteor explosion in modern times. In 1908, in a remote region of central Siberia. A blue-white fireball, which some described as brighter than the sun, exploded with the force of a 10 to 15 megaton hydrogen bomb. The explosion felled some 60 million trees across an area of 2,000 square kilometers. Yet some trees near the blast center were not burnt, and a ring of burnt trees circling the epicenter was left standing. The thunderous sounds were accompanied by a shock wave, which knocked people off their feet and broke windows hundreds of kilometers away. The explosion registered on seismic stations across Europe and Asia, and as far away as Britain, meteorologists registered fluctuations in atmospheric pressure. The resulting pulse of air pressure circled the Earth twice, and astronomers observed for several nights afterwards a glowing red haze in the upper atmosphere, though they were not aware of the cause at the time. Curiously, as noted in the Australian Journal of Astronomy in 1993, the Sir Douglas Mawson expedition in Antarctica reported an extensive auroral display a few hours before the Tunguska event. Many historical accounts also exist of strange weather, including lightning and thunder, and even seismic activity well before the devastating explosion. Despite occasional claims to the contrary, no impact crater for the intruding body has ever been found, nor the remains of an impactor, although some have occasionally claimed to have discovered Tunguska meteorite fragments. Nevertheless, Tunguska remains officially classified as the largest impact event ever recorded on Earth. In an electric universe, the energy released from an intruding comet, asteroid, or meteor is not limited by its mass and kinetic energy, but also the electrical energy due to its charge differential with Earth. This viewpoint also finds support in the largest meteor explosion to have happened on Earth since Tunguska in 2013 over the Chelyabinsk region in Russia. Initial estimates coming from the Russian Academy of Sciences stated that the space rock weighed only about 10 tons. However, based on infrasound data from as far away as Greenland and Africa, the estimation of the rock's size increased by about 1,000 times. In other words, the actual energies produced in the event were exponentially higher than the visual evidence would have suggested. From the electric universe perspective, intruding comets and asteroids do indeed pose a threat to human life, but the havoc these bodies might wreak will likely be limited to localized disasters. Perhaps a series of Tunguska-like events producing a regional devastation with falls of sand and dust. Perhaps electrical craters, fires, and earthquakes. But no single, quote, impact crater at all. Indeed, we cannot overemphasize the need for planetary scientists to completely reassess the theory of planetary cratering. For many decades, laboratory experiments into electrical discharge have reproduced common planetary surface features, which defy impact theory. These unique forms include stunning crater chains, such as these dramatic examples on the Jovian moon Ganymede, on Mercury, Mars, and the Martian moon Phobos. It includes bizarre polygonal craters, seen rather commonly in the solar system, and which impact experiments simply do not produce, but which are produced by electrical discharge. It includes craters with weird concentric circles, such as Richat crater in the Saharan Desert, Silver Pit crater in the North Sea off of Great Britain, and Valhalla crater on Jupiter's moon Callisto. It includes impossibly huge craters, that is, craters so large that any impact which created them would have shattered the body on which they appear. It includes bizarrely aligned craters, such as these seen at the Nachos Terra region of Mars, and even so-called bullseye craters, that is, craters with internal craters, which would require that two impactors in remarkably close proximity strike with perfect central precision in each of the craters. However, craters with internal central craters is routinely seen in the industrial process of electrical discharge machining. At the aforementioned alleged impact site in the city of Tal el Hammam, the investigators point to the presence of tiny spherules and, quote, shocked quartz as proof of a kinetic impact. But as we've exhaustively documented, a routine result of electrical discharge is the production of spherules, perhaps most famously demonstrated in plasma physicist Dr. C.J. Ransom's experiments, which reproduced the so-called Martian blueberries. And additionally, it's now speculated in mainstream scientific literature that a so-called diamond rain is produced by intense lightning in the atmospheres of the gas giants Saturn and Jupiter. The irony of the aforementioned investigation is that the authors acknowledge that the ancient disaster may have been recorded as an historical account, as the biblical story of Sodom. However, as emphatically demonstrated by the reconstructions offered by mytho-historians such as David Talbot, Ev Cochrane, and Eduardo Cardona, no understanding of the ancient accounts of celestial catastrophe is possible based on the conventional perspective of the solar system's recent history. Global myth, folklore, and religious texts are testimonies to celestial events which require radically new perspectives in numerous scientific and academic disciplines, and none more so than astronomy, with its long-standing assumption of an electrically neutral universe.